Hello my dear students, in before class we study about vector analysis, introduction, types of quantities, representation of vector and types of vectors, and addition of vectors by different methods. In this class we can study about product of two vectors. In this class we study about product of two vectors. In before class we study about addition and subtraction. In this we study about product of two vectors. Firstly, the product of two vectors is of two types. One is scalar product and also called as dot product. Second one is vector product and also called as cross product. Remember these names. First one is scalar product called as dot product. Second one is vector product called as cross product. Now we learn more about scalar product, are also called dot product. If vector A and vector B any two vectors, then there is a scalar or a dot product is denoted by A dot B, and we read it as A dot B. A dot B, we read like this, and it is defined as A dot B is equal to A vector A into vector B into cos theta. This is we write as AB cos theta, where A and B are the magnitude of vector A and vector B respectively. A and B magnitude of vector A and vector B respectively, and theta is the angle between A and B. Theta is angle between vector A and vector B. Angle between them is called theta. So we write it as AB cos theta. And now vector A dot vector B is equal to scalar. We know this is a scalar product. The result is also a scalar. Vector A dot vector B is equal to magnitude only. By the definition we know already this. The scalar is nothing but it has magnitude only, no direction. So the product of A dot B is magnitude only. For this dot product or scalar product, the very important actually, important note are given below. Those are the dot product of two vectors is commutative. A dot B is equal to B dot A. This is first point. And now the second point is if theta is equal to 90 degree, nothing but cos theta, cos 90 degree is equal to 0. We know that cos 0 is equal to 1, cos 90 degree is equal to 0. By this cos 90 degree is equal to 0. In this case A dot B is equal to 0, because anything is multiplied by 0 is 0. So the vector A and B perpendicular to each other. Theta is 90 degree means A, B perpendicular to each other. By this we can write I dot J is equal to 0, J dot K is equal to 0, and finally K dot I is equal to 0. Remember this, I dot J is equal to 0, J dot K is equal to 0, K dot I is equal to 0. And next point is if theta is equal to 0, cos 0 is equal to 1, then I dot I is equal to 1, J dot J is equal to 1, K dot K is equal to 1. By this, if A equal to AXI plus AYJ and B equal to BXI plus BYJ. Now A dot B is equal to AX plus BX plus AY into BY. Here we see AX into BX and I is equal to 1. So we write AX into BX. Here AY into BY, J into J is equal to 1. So we write AY into BY. This is example. What we see above, these notes are very important for next problem. So you remember this. and this importantly. Now we can see one more example. If a equal to 2i plus 3j plus 4k and b equal to 4i plus 7j plus 8k, find a dot b dot product. Remember this, these nodes are only for dot products. So a dot b is equal to, we write as it is, 2i plus 3j plus 4k dot b equal to 4i plus 7j plus 8k. In scalar product we multiply like this: I, j, k, k. These components should be multiple like this: 4 into 2 8, I cross I dot I plus 3 into 7 21, j dot j plus 8 into 4 32 and k dot k. By this, by note, we know this: I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. By this we write 8 plus 21 plus 32. The result is a dot b is equal to, add those 61 units. In this, result also is a scalar. In this, second type is vector or cross product. Vector or cross product. Remember these names. This is cross product. If a, vector a and vector b, any two vectors, then their vector product or cross product. Vector product or cross product denoted by a cross b. Read as a cross b. We write like this and we write like this, and it is defined as a cross b is equal to vector a, vector b sin theta and unit vector n. AB sin theta into n. N is called a unit vector, where a and b are magnitudes of vector a and vector b. Theta is the angle between a and b, and n cap is unit vector such that a and b and n from the right-handed system. Right-handed thumb rule is by right hand we can show that this, the above finger is called, this finger is called unit vector n, and this is called a, vector a, and this is called vector b. These are perpendicular to each other. So by this right hand thumb rule we can write these nodes here by the figure. This is vector a, vector b, this is vector n, unit vector n. And the important notes for vector product or cross product is given below. First we denoted a cross b is equal to c. Here a cross b is equal to c. Vector a cross vector b is equal to vector c. The resultant also a vector, and this is equal to ab sin theta, and ab sin theta is magnitude of vector c and is equal to c. Here we see. Second note is, if theta is equal to 0, then sin 0 is equal to 0. Sin 0 is equal to 0. Then the cross product of parallel vectors is I cross I is equal to j cross j is equal to k cross k is equal to 0. In the before scalar product we see I cross I is equal to 1, j cross j is equal to 1, k cross k is equal to 1. But here in the cross product, I cross I is equal to 0, j cross j is equal to 0, k cross k is equal to 0. These three are equal to 0. And next one is I cross j is equal to k, j cross k is equal to I, and k cross I is equal to j. I j k. I cross j is equal to k. J cross k is equal to I. K cross I is equal to j. Like this we can write this. And last point is the cross product is non-commutative. A cross b is not equal to b cross a. In fact, vector b cross product of vector a is equal to minus of a cross b. And by this we can also write j cross I is equal to minus k. K cross j equal to minus I, and I cross k is equal to minus j. Remember these notes for next problems, very important notes. Now here is example for cross product. If a equal to 2i plus 3j and b equal to 3i plus 4j, find a cross b. We can find a cross b here.